morning, good afternoon, and good evening. This is Jason Grant here. I want to kick off Wireless Tuesday. This is, by the way, the last installment of Wireless Tuesday for 2017. I'm really excited that you are with us today. It's a great topic. Wireless Tuesday Season 1, hopefully that sounds appropriately cheesy, is now on iTunes as a podcast. So you can go back full HD video, so you can watch all of the demos of Patrick Croak doing Wi-Fi optimization. We can see Robert Rulak doing all of the ICE demos for ICE guest access. All of it was great. I've actually reviewed all of it recently. So if you have a nice long commute on a train, on a car, in a plane, download that podcast and you can check it out. It is on iTunes. As soon as I get approved on Spotify, it'll be on Spotify too. I would love to say award-winning, so if you have any awards to give out, please, I'd be happy to say award-winning podcast. This is the podcast live streaming event. We are using WebEx Event Center. So if you used a WebEx meeting in the past, you might notice a couple of things that are a little bit different. If you are having trouble seeing or hearing, I'd love you to chat the panelists and get some help. Obviously, if you can't hear me say this, then hopefully you can see this. But chat, and then make sure it says send to, and then all panelists, because if you get it sent to me and I'm in full screen mode, I might not see it. But send it to all panelists. We have several here to help out. If you have a question, there is a Q&A panel. This Q&A panel does capture the questions, and I'll sanitize the questions and post them out to Cisco Full Bars and the Wireless Friday landing page. We are recording this event, so you'll be able to check it out, and it will be posted as a podcast probably later today. It's my hope. At the end of this live event, if you attended, you will receive a poll. At the end of that poll, I would love for you to give us fives. Now, it's three simple questions. Could you see and hear well? Content met expectations, and the delivery was clear and concise. If we didn't get a 5, then don't give us a 5. Tell us what we could have done to earn your 5. But we definitely want to go for 5s. And that kicks it off for the housekeeping portion of Wireless Tuesday. I'm really excited to announce that we have Senior Product Manager, Technical Engineering, Darryl Sladden, on the line with us today. Today's hosts, I would like to give honorable mention to my team, Brad Kincaid, Russ Johnson, and Mark Delaval. I think Mark Delaval is traveling, so he's probably going to join a little bit late, so but that's all right. But anyway, I'm going to pass it off to Darryl. And again, if you have any questions, please use the Q&A panel. I might interrupt. And I was just informed that I misspelled my boss's last name.
Well, you don't want to do that.
Yeah. So I'll get that fixed. Mark, if you're reading the recording, if you're listening to the recording, I do apologize for misspelling your last name. It won't happen again unless I use the same template for next month, and then I apologize again. Anyway, with that, Darryl, are you ready to kick off? Good.
Yes,
okay,
I
Darryl,
am. Thank you very much, Jason.
I'm going to pass the ball over to you. Hopefully you've noticed I've set the bar appropriately low for you, so you should be able to jump over it without a problem.
That's what I'm looking for. Well, thank you. And again, my name is Darryl Sladden. I'm the Senior Technical Product Manager on our location-based services. I'm very glad to be invited to the last episode of Wireless Tuesdays. I hope we'll be able to give you some information about how location works with our network and ask any individual questions that we might have. Hopefully, I'm just going to jump right into a bunch of details. And there's some new stuff that maybe people aren't completely familiar with, and we'll try to make sure to expose how all this stuff works and why you're going to want to use it. So let's just start with, I've got an agenda, so we're going to make sure to finish down in this 60 minutes, but we'll give you lots of different content. You'll see we're going to start with location systems architectures and go all the way down to be able to show what products calculate the location of devices and what products consume the location devices. This is really a sort of a two-headed component, because as you start to have better and better understanding of device locations, you can have better and better applications. And that's the two, the hand-in-hand capabilities that we're working with at Cisco. So first, starting at the top, right, what's a location system architecture? It really is, just going back to the traditional how locations are calculated. A lot of science has happened in this area for the last 10 years, but we've had some really good new innovations. But just to understand that everyone has the framework, each AP is placed on a map. Every AP has a known path loss model, which is what's called an open-ear path loss, meaning as I get farther and farther away, I get less and less quieter. Doppler effect, great stuff that we all learned in high school science that you now get to take advantage of. I'm a mathematician, so I love this part of the calculations that actually show as I get farther away, my signal strength degrades, and then if I get that data from multiple APs with the same packet that's sent to multiple APs, it's called a probe packet, then I can use that to calculate the location. And locations don't always end up in exactly a single point. That's when we have the idea of minimizing the error. So I'm saying, yeah, if these three guys kind of guess I'm about a 7, I'm about a 9, and I'm about an 8, well, we average it out to be about an 8, and that's how we come up with these locations. So the distance from each individual AP is calculated, and that's the location. So that's the base of the mathematics. But then we have a bunch of additional math that we've added, things like machine learning and things like phased array antennas that continue to get the location more and more accurate. But this is always the first important part of it, is the traditional RSSI-based location. And then what are the components, right? The components of a location architecture really say, well, I'm going to start with my access points. That's the real first thing at the bottom layer. They acquire data, right? So that they acquire the data that says this cell phone client is transmitting. I'm connected to an AP. I'm heard at this signal strength. This BLE device is heard at this signal strength. This set of data is all captured at the access points. The access points then send this information up to our connected mobile experience. That's CMX. First thing, it's a big mathematical calculation engine, and it provides a bunch of analytics based on the data that we get in. It requires sort of two things. It needs a map, which is that sort of prime map that comes in and says, this access point is in room 1, this access point's in room 2. And the physical exact location of that access point is what we use in reference to determine the other location of everything else. All client location is in reference to existing access points. So that's why it's so important for you to spend time in Prime to place your access points correctly. And then what do you do with that location? So now that I've got a great location, I've calculated, yeah, I know this Wi-Fi-based microphone is on this desk. I know the Sonos is right here. I know that Darryl has walked in and his client is in the middle of this room. I start to use that information for either third-party applications or our own Cisco web-based applications. That's the final component that makes up this hierarchy of a location-based architecture. But when you do this, there's one sort of twist, is that, well, what if I don't have Prime? What if the APs are not placed on a map? Is there anything I can still do? And so we do have technologies that allow you to do that. So if APs aren't placed on a map, well, I can't really calculate how far, or I can't give you an XY because I don't have a XY to reference them. But if I don't have them, I can give you what's called presence. So just to be clear what presence is, it says, yeah, I know that I have a series of APs. I don't know where exactly they are, but I know that my client, my MAC address of my client is close to those APs. So I'm able to determine that this MAC address of this AP is close to this particular client. I'm also able to maybe group a bunch of APs together, all the APs that are in a lobby or in a conference room, and say, yeah, I know you're somewhere close to those APs. And so I can say how long you've been close to those APs and how close you are. So without a map, I can still do some pretty interesting capabilities. And it's an important component to know, because maybe you haven't gone through and placed all your APs on a map. If you haven't, what we can tell you is how many and how close you are to particular APs. However, if you do have Prime, that is the right way. That is the overall direction that you should be looking at in order to provide an optimized solution, is place your APs on a map, then we can provide a reference location. Things you can do is, hey, which floor am I looking at? When we first determine a location, the first thing we do is we say, which APs do I hear you from the most? Right, I have 20 APs on floor A, I have 10 APs on floor B. First thing I do in my algorithms is what's called a pick floor algorithm. It says, are you on floor A or are you on floor B? And that's the first thing. And then once I know you're on floor A, then I can use the distance from every AP to determine where you are with an XY on floor A. So that's the real location options. If I have Prime, always want to put Prime in. If you don't, try to get them, try to move towards Prime. If you don't have Prime, you can still provide some locations based on the presence algorithms. Generally, the way presence algorithms work is which AP am I closest to. Okay, but then, so now that I know I need Prime, I need my wireless LAN controller, and I need CMX to calculate these locations. What does each of one of these three do, and what are the recommended releases for these? Well, with Prime, we really want to go with Prime 3.1 or 3.2. There's been a lot of versions of Prime, and Prime for CMX works all the way back to version 2.1. So there's a lot, if you have an older version, you can still use it, but things that you're going to get, you get better and better capabilities with the more recent versions of Prime. Prime 3.1, you have the ability to do what's called referential placement of APs. The really great solution that says, yeah, if I have a really big map, think of an airport, right? Think of an airport that's got like 70 or 80,000 square feet, 200,000 square feet. If I have to drag an AP onto that map, it can be really difficult to accurately replace that AP. But what I can do with Prime 3.1 is say, yeah, I don't know exactly where that AP is, but I know it's 10 feet from pole A and 10 feet from pole B and 5 feet from wall C. So instead of having to absolutely maybe get this drag and drop to my location that can be kind of incorrect, I can just provide what's called reference points, maybe wall A and wall B. If I know that I'm 10 meters from wall A and 5 meters from wall B, I can just provide those two reference points and it will drop the AP in the right spot. So it makes it much easier to place APs in a large venue by using referential AP placement. And in addition, you can now pull information that says where are my clients located and show them in Prime when you connect to CMX 10.3. Previously, you had to do that with MSE 8. Now you can do that with CMX. And again, Prime continues to provide additional advancements. Prime 3.2 is out. That's going to also show you where rogue APs are. So the idea of a security system that says, hey, somebody is broadcasting my SSID. At Cisco, we have an SSID called Blizzard. If anybody else were to broadcast Blizzard, hey, we need to go find those guys and shut them down. And so that's something you can now show in Prime 3.2 with CMX. For your wireless LAN controller, well, what versions are you going to recommend? Well, 7.6 all the way up to 8.6 or what's posted on CCO, but the recommended images that you want to start with is at least 8.3 MR3. Last week they talked about the crack vulnerabilities. That crack fix is posted in 8.3.133. That's sort of the baseline that I'd recommend for providing you good location-based services. It has a lot of the capabilities, it supports the new access points, provides you the right infrastructure. But then 8.6 is a great new release, just came out, and it has amazing new features that we continue to improve location. The big new feature that we've got for our 2800 and 3800 APs is what's called Fast Locate. And that's the ability to provide more location updates, because not only do I use probe packets, I also use data packets. So when I'm just connected to one channel on one AP, other APs can sort of go, yeah, I'm going to go into what's called promiscuous mode, listen to that other data stream, and help provide location on them. It provides a much more higher number of updates per minute when I start using Fast Locate on the 28s and 3800s, and that's a new feature of 8.6. And we've also got a whole new set of USB capabilities. So this USB allows you to do BLE management and BLE location. So this is a new beta feature that's in 8.6, where you can add a BLE dedicated radio, right? So now you can put in a USB-based BLE radio. That BLE radio can now detect the location of BLE devices and provide you the management of that BLE, what am I going to broadcast out and what am I going to receive. So it's great new capabilities of wireless LAN controller 8.6. And then finally on CMX, we just released this week CMX 10.4. That's going to be the recommended release. Again, it supports a lot of these new USB-based solutions for the BLE, as well as got some additional bug fixes and rogue APs and a great new sets of features. So that's really what we're going to recommend. Prime 3.1, wireless LAN controller 8.3 or later, and CMX 10.4. Those are the releases that are really going to be the ones that will make the location solution the most robust. All right, so let's just dial back into how these packets are processed. So first of all, the traditional, it's called NMSP Packet. So network management packets are ones that come from my wireless LAN controller and go to my MSE-based boxes that calculate the location that run the CMX software. And so what happens is APs say, yeah, I hear a MAC address of this particular MAC address at this strength. Other APs are doing the same thing. That says, hey, I hear that same MAC address at a different strength. Remember those circles? They're all individual broadcasts are from the packet. They all have the same MAC address, but different AP hear them at different strengths. And all of those APs then send all that information up through the control tunnel up to the wireless LAN controller. The wireless LAN controller has a bus infrastructure, and that bus says, yeah, I'm going to wait every 2 seconds. I'm going to gather all the data that I see, put that on the bus, and send it off via NMSP packets to my different MSEs. Okay, so I then create an NMSP packet that says, yep, I've got this information from AP1 and AP2, put it all into a list, and anyone who's on what's called my off list, so it's a set of configurations on my wireless LAN controller that says, who am I going to trust to send this data to? I send it to each one of those guys. And so that's how the final MSE gets the data that says, hey, how do I calculate a location? And that can be sent to up to 4 different MSEs, and they say, yep, I've got this location for this particular, I've got this set of data about this MAC address, I'm going to calculate a location. There's a cutoff information and some cutoff values that say, yeah, it's the signal strength of that location data, meaning I got an RSSI value of, minus 95 or minus 88. That's a really, really low values. I can say, yeah, I'm going to ignore them. That's too low value. It's not enough noise, not enough information for me to give me a really good location. So I can decide to cut off, and if I don't, I can then calculate the location. But there's a new type of packet, and this is something that people need to understand, that this is a new part of the architecture. People who have been working in wireless for a long time may have sort of not seen this new type of what's called FastPath packet that goes over port 2003. So this new data is what's called our angle of arrival, or our FastPath data. A bit of a mouthful. So new APs have the ability to also have what's called a phase array antenna. People might have been, anyone who was in the know, the least kept secret was the word halo. Yeah, this was our halo antenna. It's a circular antenna, which is why we called it that's why it got the nickname the halo, around an access point. So it would go around the 3700 or the 3600, and it would actually be able to provide additional phase array data that says which antenna, I have 32 antennas around in the circle, which antenna did it hear first, antenna 1, 2, 3, 4, and as I receive data packets, it would be able to give you what's called a phase data analysis, and that's a bunch of big, huge hunk of data. So that wasn't appropriate to go in the NMSP channel, so we actually created a new set of data paths that go from the AP to the MSE to calculate the location. This is called the FastPath. This is stuff that goes over a UDP port because it's sort of unidirectional from the AP to the MSE to calculate the location. It's over this new port 2003. So if you've got your port sniffers, you're going to start to see, hey, what the heck is this data coming off the AP? It's not client data. It's not associated. It's not CapLab data. It's not any of my traditional NMSP data. It's a new data type, and that's port 2003 called FastPath data, encapsulated as it's encrypted in a UDP packet that comes from the AP out to the MSE, and then it uses that to also calculate the location. So the MSE decrypts that information and uses that additional information to calculate the location. So it's got two sets of data. This FastPath data that includes this angle of arrival or any other FastPath data that we decide to put into that. So we actually have another tunnel that says, hey, I need to get data from the AP all the way to the MSE to calculate the location. I put my BLE data in there. I put information about the angle of arrivals for the HyperLocation antenna in there, and I put the FastPath, it's called data packet RSSI. So if my client is on a different channel, but I need to still send information about the signal strength, instead of putting it in the NMSP, I also put that in the FastPath. So FastPath is a new set of data packets that come from the AP out to the MSE to calculate the location. There's when you actually do that, there's a couple of different good and bad. There's always pros and cons for every type of capability. So NMSP-based data packets, right? They have, AP generates them, the RSSI value puts in the CapLab tunnel, the wireless LAN controller grabs them all every 2 seconds, sends them off to the to the MSE, very traditional architecture that we've had. The pros are there's a lot of redundancy, but it does provide an additional delay, right? Because the wireless LAN controller is now in the path, right? It's why we called the other one FastPath is because that one's going to be faster than the traditional NMSP base. The NMSP means everybody has to send data to the controller, and then the controller creates the packet. The controller created packet is then sent. So we have everything wait at the controller. Controller creates a packet every 2 seconds and sends it off. In the FastPath, the AP creates the packet. So we've moved all of the location data straight into the AP. The AP actually creates the complete end packet, pops it into that cap-lap tunnel. The wireless LAN controller doesn't do any aggregation, just pops it straight on and off. So you get a much faster set of determinations. But because of that, each AP is going to send it, has the IP address of who it's sending it to, right? So it's not a one-to-many, it's a one-to-one. The AP says, yeah, who am I going to send it to? Control path information tells the AP, depending on configuration, what server should I be sending data to? But that's still going to be, the AP will send it to one server for calculating that location. And that's really the new set of gate capabilities in the FastPath. FastPath, again, with wireless LAN controller 8.6, supports the 2800s and 3800s. With 8.3, supports some of the older APs. So all of our APs moving forward will have the concept of a fast path as well as the traditional NMSP path for getting data from an AP to a CMX server, previously called MSE. That's a really important new capability. I wanted to emphasize that. How do you enable the fast path? Well, on your wireless LAN controller, there's a little thing called HyperLocation configuration parameters. We've kind of overused that one word for FastPath and for HyperLocation. So when you actually enable that, you're enabling the FastPath path that says this AP will start creating end packets. The wireless LAN controller won't actually recreate those packets. It'll just forward them off and get them to the right CMX that instance that it needs to for calculating those locations. So inside of the wireless LAN controller, you're going to see this config, which is the enable hyperlocation. You don't actually give it an IP address of who it sends to. That's learned in the control message. You do give it an IP address of an NTP server. So what this is that every single AP now is going to run an NTP client because all those APs need to timestamp those packets to make sure they're all sent at the same time. Right? Previously was since they all gathered onto the bus on the wireless LAN controller, just the wireless LAN controller would have a clock. Now, every AP has an NTP client also. Not a server, but an NTP client. And so we have to say, which APs am I going to, you talk to which particular NTP server. And we've also had a couple of other parameters, such as a packet detection RSSI minimum, meaning if this AP detects a signal strength that's really very quiet, don't even bother sending that data. We can start cutting those data off. And then finally, on CMX, you also have to do that both sides. So both sides have to kind of agree that we're going to be receiving this fast path data. And so in CMX, the box is called Enable HyperLocation FastPath BLE Management, because we know we've overloaded this particular method of getting data from an AP to a CMX with multiple types of data. And so in the CMX, you've actually got all those three types of data that are shown. And so that word hyperlocation means both fast path and angle of arrival. It's an important new concept in location that's just been added. Okay. Now, I beat that to death, but I do want to give you a little bit more of the science around hyperlocation to make sure we're all clear about that. Really, what hyperlocation has added has been, we were previously looked at the distance of every single AP. So we showed you those circles that every single AP has a path loss, meaning when I get farther and farther away from an AP, I get quieter and quieter. When I'm really close to the AP, I'm really loud, right? And so I can use those to create 3 concentric circles and then use that math to determine a location in the center. But now, with angle of arrival and hyperlocation, I can also use an additional set of data. That is, I can use the direction that a client is coming from. So that direction means not only do I know how far it is, but I can know that it's on a 70-degree angle. This one's at a 45-degree angle. This one's at a 23-degree angle. So it really provides a much more accurate location. How much more accurate? well, I can get to the location to within 1 to 3 meters as opposed to traditional 5 to 7 meters location accuracy. So this is really the advantage that comes down. This is kind of the science that we always want to put this on. It's called our cumulative distribution of errors. We are very conservative at Cisco. We put a lot of science behind when we're saying how accurate this location is, and that's really what we spend a lot of time proving. So maybe other customers might have just put down how close this solution is, but we actually say that at a particular error rate, which is within 2 meters. If I have traditional location, I'm going to get only 10% of those devices within 2 meters. But and so that's how I read that little 10%, 10 at the bottom with the 2. But with this top bar that says within 2 meters, I'm going to get almost 50% of my clients correctly located within 2 meters. And that's really the difference that occurs with the improvement of hyperlocation. I get much more clients that I'm within a couple meters location accuracy. How is that done? Just to be clear, hyperlocation antennas are programmed that says which APs is close to around me. Remember, we showed you those APs that had those angles that all came from. I have to know who my neighbors are. So instead of a CDP neighborhood list, in hyperlocation, it's called an L1 neighborhood list. So it actually says for every AP, I form sort of groups and say, hey, who's my neighbor? Who's the closest guys who are going to help me in calculating the location of a client? So it's a surrounding APs. It's called an L1 list. But if a client is actually not sending packets and I want to determine the location of that client, I'm going to have to say, well, there's a MAC address that's associated with me, but he's not sending any packets, so I can't tell what angle he's coming from. In that case, we wake up the client by sending what's called a bar and a bar act. So the AP says, hey, who are you there? Are you there? By sending out a packet, and the client is forced by the standards to wake up and say, yep, here's my response. And so with those bar and bar act packets, we can then determine the location of clients. It's important to note that we only calculate the location of associated clients. So no probing clients, no RFID tags, no BLE at this point. The existing shipping technologies are for associated clients. And in 2018, we're going to start to expand that portfolio to calculate the location of other devices. But currently, hyperlocation calculates the clients that are associated to that AP. Because every AP has, what clients are associated to. It's called an association list. That association list is used to feed, the rest of the algorithm. Finally, when I have that angle of arrival, I also get the angle of arrival and the RSSI data, and I what's called fuse them together. And so this is our fusion algorithm. So we'll see a lot of times that we'll say the location is a fusion of both the received signal strength and the angle of arrival, and that's how we calculate a final location. So that's really all there is about hyperlocation. It's a great new technology. It's going to revolutionize the way, and it's really revolutionizing the way people can provide more and more services to associated clients. So as you join the Wi-Fi, the location accuracy goes dramatically better. You're able to do things like determine whether or not he's in a room or out of room. We're able to send advertisements to a very narrow set of locations. We're able to have a much improved location calculation. So it's not that sort of 5 to 7 meter error that we're kind of previously looking at now for associated clients, even if I don't run an app. And that's really important because previously you have to always run an app for other location technologies. Now, without running an app, I know where a device is within the 1 to 3 meters. Okay, the next thing I wanted to talk a little bit about was the whole CMX 10, right? So CMX 10 software architecture is a big dramatic change from our older technologies, which was around MSE 8. And really the big change for it is we previously had a single threaded Oracle database that was the one sort of centralized thing that connected. So anytime we got these NMSP messages from the APs and from the wireless LAN controller, we'd pop them into Oracle database. Then when we needed to calculate location, we'd pull it back. All of our analytics was done in this Oracle database. So any people might have had cases that they've opened about things like, alerts or logs, or an Oracle database having a bunch of logs that are written to the disk and the disk is filled up and my MSE has stopped working. Or I'm trying to get into my MSE, but the Oracle database is saying, no, it refuses all connections. So we had a lot of issues that we really couldn't deal with end-to-end because we didn't control the database inside of the MSE. We were using this database, but we didn't get to control it end-to-end. And so we made this tough architectural decision about 2 years ago to rewrite the whole solution without using the Oracle database. So we use some open source databases that allow us to really control our own destiny. So if there's a bug, much more on us. If there's an issue, we can provide the patches immediately. So this new solution with CMX 10 scales higher because we're now using Redis, which is a in-memory storage of key values. We use a Postgres database. We use a Cassandra instance. So we have a bunch of caches that are all in-memory solutions that's really using a much more modern architecture. So this Cassandra, Redis, and Postgres allows us to really scale, right? We're not sort of hamstrung by kind of older client-server technology. Now we're using a much more a key value web solutions. And so now we've got that much higher ability to scale. So that's really the big architectural change that occurs in CMX 10. Okay, now let's go on to the next step, which is, we're talking about best practices. We want to make sure where the APs need to be placed for this best practices, right? And so AP placement for location and best practices. First of all, HyperLocation APs have a direction. Some of the older APs, they don't. But when you have a HyperLocation APs, you need to have a little direction. There's a little arrow. Here it's shown as a black mark. It's not really black inside of the actual HyperLocation. It's just a little indented piece of the plastic where you can actually see what direction an AP is pointed in. But you need to get the APs pointed in the right direction if they're HyperLocation APs. So that's an important new requirement when placing HyperLocation APs. You want to install the APs on the ceiling grid. Try to align the arrows in the same way just so you have less chance of finding errors. But when you're actually placing the APs, staggering them and creating triangles, right? Think of all the wonderful graphics that you see in Pixar films. Those are all created by triangles. Triangles are wonderful shapes for determining location and mathematics. They're great shapes for math. So that's why we want the APs to be placed so that there are a bunch of triangles. All the areas within the triangles are called the convex hull. So when I'm within the triangles. So we want to be able to have the APs staggered, so not in a complete straight line, move them stagger up and down along a line, and about one AP every 2,500 square feet. I see a lot of customers actually go to one every 1,500 square feet, and I'm all for that. I think we want to get more APs. About one every 1,500 square feet is best practice. I know not everyone can maybe afford that, so you can absolutely get still location with one every 25, but as you move towards one every 1,500, 1,600 square feet, you're going to get really great density, really great solutions, and really great location calculations. And also, all buildings aren't square, right? One of the important things to note is that, yeah, you're going to have all these weird angles, right, on buildings that are different shapes. You still need to understand that the direction that you actually go in for the arrow needs to be correctly reflected in Prime. So in Prime, it's the single source of truth. Prime then pulls the map into CMX, but you've got to get that map set based on your actual orientation. So 270 is always up, 0 is always to the right, and so you've got to actually make sure that in your particular map that you have the right orientation created. And then finally, the best practices for, we're showing this down a hall here, serpentine, right? An AP on the left, an AP on the right, an AP on the left, an AP on the right. That's going to get you better location because we can actually create all these triangles. You put them all straight down the center, you're not going to get as good location accuracy. So here's this bottom part where it says not recommended. And then secondly, if you have devices that are outside of the convex hull, meaning if I have a device that, I can still see a couple of APs, but we're not seeing them from the inside, we're seeing them from outside, which is, you're not going to get as good location accuracy in this area. Again, the outside convex hull. You see here on the far left, device APs around the edge, then APs added into the center are what's going to get you the best location. You don't need to cover the entire perimeter of every building, but if you try to stagger them, put the APs around the edge, this is going to give you a much better location accuracy. So let's go over some of these just best practices we kind of talked about. Location accuracy, put clients within the convex hull. So put APs around the edge, clients in the inside. That will give us the best location accuracy. You're going to kind of lose some, you've got coverage that you've got providing on the edge that you're not going to be kind of using. But if you're looking for location accuracy, that's going to give you the best capabilities inside the convex hull. To do that, you place APs in the outer walls and then move in. Then you sort of start filling in from the center. Clients, individual clients, anytime I did an Echo House survey, I want to hear at least 3 APs at -70 dBm or better, right? If I actually need to hear at least 3 APs, so I can start to do those triangulation capabilities. Thick walls. If I have some big giant concrete wall that is a huge amount of attenuation, we need to model that as part of our science for modeling what's called the open air path loss. We actually model thick walls with a 17 dB path loss, so you actually need to enter them in Prime. So if I have a big thick wall means not a dry wall, not a regular sort of thin wall, not a regular door, but a big thick concrete wall. Enter them into Prime so we can model that as part of our open air path loss. Also, if I have areas that are impossible for a client to physically be in, right? It's called exclusion zones. Maybe it's an open air space in an atrium, something like that. Put them into Prime because it helps us build the mathematical model of the location better. And then finally, pick a calibration model. I don't recommend redoing calibrations, but inside of Prime, there's a concept of picking a calibration model. There's only 4. Indoor carpeted, indoor high ceilings. Pick a calibration model. The most widely used is the indoor carpeted calibration model. Pick that calibration model and stick with it, or pick the one that's most appropriate for your venue. Those are really the practices that will give you the most accurate location calculations. All right, and so when I'm calculating the location, how do I calculate it for different types of entities, right? I not only have those associated clients, I have other stuff in my network. How do I calculate the location? Well, there's a couple of different things in your location, right? The first one is clients. Clients that are associated with my network, whether it's 2.4 or 5 gigahertz clients. Probe packets are the most basic type of location accuracy. And so with probe client location accuracy, I can get, about 10 meters, but my typical location accuracy is 5 to 7 meters. And when I use the angle of arrival, I can get my best, which is that 1 to 3 meter location accuracy. And so that's how I calculate the location of a 2.4 or 5 gigahertz client that's on my network. Those clients can either be associated clients or probing-only clients. Probing-only clients will give you only probe-based location. Associated clients give you that better location for either angle of arrival or data packet or SSI. The second type of device that's on my network is an interferer, right? If somebody is using up my precious 2.4 or 5 gigahertz spectrum, I need to know where they are in order to go hunt that guy down, tell him to turn off his cell phone or his turn off his DECT phone or turn off that microwave. So clean air, which is what's used by Cisco to detect interference, can determine the location of a client to within, about 5 to 7 meters, right? So we'll be able to use that by triangulating. And then RFID tags. So historically, the big component of tracking valuable assets has been take an RFID tag. An RFID tag is a Wi-Fi chipset that's really just designed to probe. So probe packets every 30 seconds, and it probes on channels 1, 6, and 11, and on a very consistent basis. And because it's so consistent, we have a lot less mass error because it's consistently broadcast on the same channel. So we get a really good location accuracy. RFID tags are really designed only for 2.4 gigahertz today. And so they probe out, you can get about 3 meter location accuracy. Rogue APs. Rogue APs are probably the one that the most security people are interested in. A rogue AP is some AP that's broadcasting in my space. So my space I define as my indoor carpeted space or my outdoor access points that are broadcasting an SSID that's similar to mine, right? If I'm Xfinity and somebody broadcasts Xfinity 1 as their SSID, I'm going to be concerned because I don't want people to accidentally think that that's an Xfinity SSID or Blizzard or any SSID that is broadcast. You see this a lot at airports, right? They might have an airport and then some person say airport 1 SSID, right? So you want to know what's going on with these other APs that are in the same data space. Again, FCC requirements, 2.4 and 5 gigahertz is a shared spectrum. You're not allowed to just denial of service or attack these other APs, but it's good to know that they're there. And so Cisco provides the tools with our Rogue AP client location determination, and how we determine the location of those Rogue APs is from the probe packets that they're sending. So those APs send that probe packet, say, yeah, I'm this guy. We can determine the location of those APs within about 5 to 7 meters. We can also determine the location of BLE devices. And so BLE devices are really two ways of doing it. One is with clean air, so it's detecting it as an interferer. And the second is that we actually are really spending a lot of time investing very heavily in is as a dedicated BLE radios. And so the Meraki APs have a dedicated BLE radio. The 1815 has a dedicated BLE radio. The 28s and 3800s through a dongle now have a dedicated BLE radio. Those dedicated BLE radios on access points, so if they have received dedicated BLE radios, can use the RSSI signal strength of BLE devices to determine very accurately the location of BLE asset tracking. So that's within 5 to 7 meters, and we get updates probably about every 5 seconds. So those are the different types of devices on your network and how accurate the location is for those individual devices. The next thing people constantly are asking me about is what's the difference between MSE and CMX? And you've seen me use some of the same terms back and forth in this presentation, but the MSE is the name for the older software, right? There was MSE 8.0, Mobility Services Engine 8.0. Before that, there was Location Engine 2710, right? The names go on for way longer than they need to. But the MSE is the name for the older software, MSE 8.0, but it also is the name for the current hardware. The current shipping hardware that we recommend is the MSE 3365. It's the existing engine. But there's the next generation, right? As we've made that switch about 2 years ago, we renamed the product to the CMX Connected Mobile Experiences, and that's the name for the current software. That's the current software. And there's also going to be some future hardware coming in the first half of next year, and that will be called CMX 3375. Name changes take a long time. Cisco customers have long memories. The MSC is the older software. The CMX is the newer software. That's kind of the easiest way to say it. And eventually, the name will completely transition into CMX. And so you'll have a CMX appliance, you have the CMX software, and the name MSC, we expect to fade away over the next X number of years as people have very long memories. So, what products does Cisco have that calculate the location? We just talked a lot about them, right? We have CMX 10.4 on-premise, calculates the location. We have two mathematical options in there. It either calculates the presence, meaning how close an AP is to a client is to a particular AP, or it does that full location calculation. You give it a map in Prime, and it will calculate the XY component of every individual client. We also have the older MSE 8, right? MSE 8.0 is still there. It's a feature-complete product. We're not adding any components to it, but the MSE 8.0 MR5 still calculates the location of clients. We also have a couple of cloud products, right? One is our Beacon Center. We're going to have another talk. Hopefully, maybe Jason will invite me back again to have a whole session just on BLE. But our BLE capabilities, which require a client application and an SDK, allow you to calculate the location for the SDK. And then we have CMX presence in the cloud. So that means you can sign up right now at cmxcloud.cisco.com for a service that will read information off your controller and tell you that instead of you having to install your own server, we'll install that presence server. And then finally, we're going to be doing another cloud service for a location in the cloud. So you'll be able to say, yeah, I don't want to maintain all the servers that are required on-premise to calculate the location of these clients. I'm going to subscribe to a service and let Cisco calculate that. And so that's on our roadmap. Look out for a beta for a CMX location in the cloud. Those last two components really show you some of the direction that we're moving, is that the ability for Cisco to provide more services that says, yeah, we understand your controller is going to be yours on-prem, keep that, but if we want to add some ancillary services, like calculating the location, you could do that on a cloud-based service, and that's what we're going to be providing. Right now you have it on-prem, but a lot of people are saying, yeah, I want another alternative. And so we'll offer that alternative of like cloud-based calculation of the location. And so now that I've calculated the location, yeah, I know that Darryl is at, in front of the lobby in front of building 4. What do I do with that, right? There's a lot of really good use cases, right? Prime is the first device that utilizes location, right? Prime uses 10.3 to show you the location of interferers and clients on a map. It's an IT troubleshooting tool. You ask it for a history. Where was the device when something happened? That's the primary location. That's the location use cases in Prime. Prime can use either CMX 10.3 or MSE 8. And then CMX Engage. That's another important product that we'll talk about. So CMX Engage says, yeah, I have calculated the location of the client, and I'm going to use this to help me engage with a customer. Well, engage means I want to send a text message that a person has arrived. I want to inform the boss that Darryl has arrived on campus. I want to let somebody know that there are more than 10 people in this particular area. As you start to have individual engagements with the customer, that's really what the product CMX Engage is all about. It's a cloud service offered by Cisco, consumes location, and starts to interact with the customer depending on where they are in a location. Very powerful solution because when you travel around the web, there's web logs everywhere you go, and your web pages change depending on what page you came from, right? An Amazon page will have different ads depending on where you came from. But now you can start to do that depending on where you are physically in a space. So imagine if you start to go into a sports venue, it'll start to say, oh, I noticed, Darryl, you're here at the sports venue. We know that your basketball game that starts in 30 minutes, you should probably get to the change room, right? You can start to have your engagement depend on where you physically are in the space. And another product that actually just consumes the location is CMX itself, right? They may be able to show you on a map where clients are, be able to provide you analytics that say this number of clients are in this space at this time, show you what day of the week is busiest, what week of the month is the busiest, whether or not I have a lot of Apple devices or Android, all those analytics data, that's all based on after a location has been calculated. Another one that we're really seeing a lot of customers see a lot of value with is Cisco Workplace Analytics. Workplace Analytics is the ability to say, yeah, now I know where everybody is. How am I going to use that? And so Cisco used that in order to determine whether or not we needed to have as many buildings as we did. We saved a lot of money in real estate by realizing a lot of people were working from home. Wi-Fi analytics determined that not a lot of people came in on Fridays, fewer people came in, maybe Wednesdays had a lot, but not so many on Tuesdays and Fridays. And we were able to use that to justify closing down additional buildings. Part of our whole workplace analytics solution that takes into account both the door badging and the Wi-Fi to determine the utilization of a building. We've got some custom applications, and the final custom we've got custom applications that the end users can use, as well as Cisco Operational Insights. And so Operational Insights is a new product that we're actually going to show you now. It really takes into account how devices calculate the location and what they've been used for. We are opening up that Operational Insights to have the ability to have a beta right now, and the contact information for that beta is Tamir, that's on the slides right now. All right, so now I wanted to show you a couple of demos. And so let's jump into that. Okay, Jason? All right, so I'm going to share.
That is a great idea. I love that. This is all great, by the way. There's a ton of great questions coming in.
Are there?
I'm going to let you get. Yeah, I'm going to let you get through your demos. I don't know if we'll have time to go through the questions live, but everyone, I'll make sure that the questions are answered, and all of the questions will be, maybe sanitized, but then posted on the Wireless Tuesday landing page.
Okay.
And,
well,
based on.
Go ahead.
Yeah, go ahead. Yep, it's all yours.
Well, yeah, so the first thing we wanted to show you is what CMX 10.4. So this is the new product that was released this week. The whole idea is this is an on-prem device, calculates the location, and now I have this overhead kind of God view map of all the devices in my network, right? And as I select any individual device, it shows me, well, how did I calculate the location of the device? It says, well, this device was seen by these different APs at this different signal strength, and that's what it was eventually used to calculate the location. It was Compute type was RSSI, so I used it as a signal strength to calculate the location. So this is kind of the overall view, but there are so many things in my network. I can try to show you the layered view. First is I show you where all the access points are, right? So there's a bunch of different access points in my network. The location of them is really important. And then I can show you where the clients are as a layer on top of that. I can show you where the rogue APs are. So these are rogue APs. This is a really dense network of mine that is in a lab, and so there's thousands of others of Cisco APs around, and all those other broadcasting APs are detected as rogues in my network, meaning, hey, there's somebody who I don't know about. And so we've got lots of rogue APs. I've got rogue clients, which are people who are associated to my network and now associated to somebody else. I don't like that. Why is somebody else there? So I can kind of find out that this client, this MAC address, seen by 3 different APs, was previously associated with me. Now it's associated with somebody else. RFID tags, BLE. And so this kind of gets to be interferers. So it kind of gets to be a bit of an eye chart. But the idea is your APs that are in the ceiling are constantly detecting lots of different types of energy, and CMX calculates and shows you the location of energy of each of them. You normally want to kind of look at them one layer at a time. So if I'm just looking for interferers in my network, I can see where there are. If I'm just looking for rogues, I can start to see where they are and take action upon them. And so that's really the whole part of CMX 10.4 is to calculating all those locations. And then it uses the analytics to make interesting decisions to say, oh, now that I know that I have all those calculated locations, I can tell you that today I have 495 visitors to my site. I can tell you how long they've been on the site. In this case, I can tell you that the percentage that are here for 0 to 5 minutes is 15%, and the guys who are here more than 3 hours are over 30%, right? And I can go on down to any individual day and show the number of individual visitors coming in. So it really provides you that overall analytics. That's the base CMX on-prem. That's the first application. The next one that you're going to say is, well, I also have a cloud-based solution. So the cloud-based solution works similar, but again, because I don't have a map, I'm just going to be able to say presence. And so presence tells you generally of all the APs in this area, how many clients have they been detected. So again, remember we talked about presence saying I can't tell you exactly where they are, but I can say I've detected 500 clients on this day. Third application we wanted to talk about was CMX Engage. CMX Engage grabs that information about your client and then does a bunch of proximity or engagement rules. An engagement rule is the idea of I click on an engagement rule and say, yeah, if you're close to the library, I want to send you a text. So an engagement rule works by doing the following, right? It says, the user is detected on Wi-Fi entering a location. You can see that I specify the sensing mechanism. I say what location he's close to. In this case, I sense that he's close to the quad. I say I only want to sense this for a certain subset of users. In this case, people who are opted in and people who previously in my CRM, I know I have a book available for that user. Opted in user, close to the quad or the library, book is available. He's coming between 9 a.m. and 6 p.m., so when the library is open, I can then send them a text. Oh, welcome back, Darryl, your book is waiting for you. Imagine that's the end-to-end capability of engaging with a customer, whether it's reminding them that the book is available, during a lunchtime, giving them a particular special, any type of thing where the system knows some information and your location helps you make that location more relevant is really have the focus of CMX Engage. We've had a lot of success on people doing things like just as basic as an exit interview. We talked about how Jason wants us to all complete this exit interview at the end of this demonstration. Imagine doing an exit interview when you actually physically leave a space. And then finally, the one I wanted to show you was Operational Insights. This is a new capability. Operational Insights is a new set of software available this month. We're going to be getting some SKUs where I can start to track assets. A cloud service that will give me an overall view that says, overall, I have 37 assets that I'm looking for. Of these assets, I can tell you which department they're related to, what category those assets are in. I can then look at that overall view of where my assets are. So I can select a particular building, in this case, building 24. I can get a mapped view and I'll zoom out and show me inside of building 24. I've got a couple of different floors. I zoom in on a floor and I can show you all the assets that I think are important on that floor. As I select an individual asset, say a desk, I can tell you how it's detected, meaning it's detected as an RFID tag, the history of where that asset has been, in this case, the asset is kind of a fixed asset, and stay in the same location. I can get a lot of information about that particular asset. But the real power is, just like I have the rule about engaging, I can create rules about these assets. In this case, maybe I want a rule that says my laser printer has gone offline, and a notification. My MDF is too hot. So people have been adding the temperature monitors to your MDF. In this case, I'm going to create a rule that says my MDF is too hot. I'm going to enable this rule, put a temperature sensor. If the temperature is higher than 70 degrees, after, immediately, I trigger immediately, I can send an SMS text to myself that says my MDF is too hot. So imagine these types of rules that can be any telemetry information that occurs throughout your network. The APs are those guys that are constantly listening for this information. And now I can create context based on that. Imagine if I can set a rule that says, hey, I have these shared iPads that are all supposed to be on building 24, and they're all supposed to be in the museum. Somebody takes one out, send a text message or a notification. I can have my MDF is too hot. I can start to have lots and lots of rules about my asset. And that's really the new capabilities around operational insight. Assets are completely listed as anything that has either a Wi-Fi chip, right? As we have more and more IoT devices, everything is beginning to be Wi-Fi enabled, or anything that I decide to tag with an RFID tag. So that's really what I wanted to talk about. I've talked about for an hour. We were going through a bunch of different solutions about how location is calculated, the MSE calculating it, and then why do I use it? I can use it for engage. I can use it for Refinity, which is our workspace analytics, or I can use it for operational insights, or you can create your own custom applications.
This is a great demo. This is really great. This is a product that's available now. You can download.
Operational Insights is a cloud-based service. Because it's a cloud-based service, you can sign up for a subscription. We've got that. We charge on a per asset per year basis, but again, free during this demo period. They can really start to take advantage of Operational Insights.
This is great. Just let me ask you a question, Darryl. And first of all, yes, you are invited back. I'd love to have you back in season 2 of Wireless Tuesday. I try to keep these down to an hour. We're right at the end of it. You mind if I close this out?
Absolutely. Go ahead.
Well, that's great. I'm going to take the ball back just for a moment so that I can just kind of close this out. Thanks for joining. Again, this is my absolute favorite day of the month. It used to be Fridays, but oddly enough, now it's Wireless Tuesday. We're gonna keep the party going. Wireless Tuesday, what I'm going to refer to as season 2, because that seems like what all the kids are doing these days is podcasting. So actually, it seems to work out really well. So be sure to subscribe to the podcast on iTunes. I have submitted this to some other carriers like Spotify, if that's your preferred mechanism for getting iTunes. But it's going to be the first Tuesday of every month, with the exception of the first month. That would make it like January 2nd. So I'm going to give everybody a break, and we'll hit the first Wireless Tuesday of 2018 on January 9th. The topic is going to be tips and tricks from Cisco TAC, and what Cisco TAC hears most, so that we can perhaps not run into those things. So I'm looking forward to that. I've got some great speakers lined up. I'll make some announcements here pretty soon. Hey, thank you for those of you who have been with us from the beginning, but even in 2016. Thank you so much for your loyalty. I appreciate it very much. I'd love to hear from you, jagrant@cisco.com, anytime. Be sure to, again, subscribe to the podcast. Have a great new year and a holiday season. I can't wait. to hear what we have in store for, or to show you what we have in store for next year. Thanks so much.